back to R&D Technologies Print Room. Today we are here with Chris Wachewski from Functional 3D. He's the founder and CEO, and we are marrying our 3D printing technology with 3D scanning today to recreate this 1970s era Poloron cooler cover for a very, very good friend of ours here at R&D Technologies. And today we're going to be scanning this piece because this piece has been cracked and it needs to be recreated, but there is no 3D CAD file for us to be able to load into GrabCAD print. So we've enlisted the help of our good friend Chris here to show us all of his technology and how he's going to scan this part and create a 3D file for us to be able to upload into our system and recreate this very, very interesting piece.
So we're going to be using today SmartTech 3D's Universe 10 scanner to capture the lid to this cooler in order to be able to bring it into the computer and recreate it. The scanner is a certified scanner down to 0.08 millimeters of accuracy, so we can provide a very accurate representation of something in the real world, bring that into the computer, and allow us to generate not only just a mesh file, but also full CAD. We can reverse engineer it and then use that information to generate some new designs with it. So we can design around it, we can design to attach to it, we can design something, even modify the current design, like adding a logo to the top of this wheel.
Once we've finished capturing all of the information, we can begin to clean up the top and the bottom portions of the scans, fine align them, and then we can align the two sides together. And we do that by selecting 3 points. And then we can finalize the alignment into a combined piece of data. And we're now ready to mesh. And so we create this triangulated mesh from all of the points that we've captured. And this can then be used in a number of applications. We can 3D print directly from this information, or go on to the next step, which is to start to create a CAD surface file for use in a full CAD package. You can see here I'm using Geomagic's Design X software to create a surface model. So we bring in the mesh and we use the Auto Surface tool to capture and recreate this information in a suitable CAD format. I'll be exporting this into an IGES. We can check the auto surface to confirm it's within our level of tolerance, that we're seeing information that should be accurate. And then we can bring the data into our CAD package of choice. So I'll be using Fusion 360 to bring in the surface file, the IGES that I created in Geomagic Design X. I will offset a plane that I will use for sketching. Use an SVG of the logo and extrude that up and combine the bodies together. We're now ready to export and get ready for printing.
Thanks, Chris. That was a great demonstration how you take the scanned file and bring it into your software to create a completed file for us to be able to use. Now I'm back here in my office a couple of days later after Chris has done his work, and now we're going to go through the process of where we take the file that Chris has completed for us and we upload it into our software, GrabCAD Print, to send to our 3D printers. Now today we're going to be using our Fortus 450, and as you can see here, we have our part file completed with the customer's logo already in. And what we're going to do is we're going to orient this part correctly to ensure a successful build, and we're also going to use a couple of features that GrabCAD has to offer. Now, GrabCAD itself is a software that's free to anyone. You can go to grabcad.com and download this software, and you can utilize it yourself. If you happen to be in the market for an industrial 3D printer, it's nice to be able to go and use the software that interfaces with the printers to get a feel before you go down the buying process. And of course, you can always find that information at our website, rnd-tech.com, and you can get information there on our printers and how to get information on how to buy a printer. Now we have our file, and we're going to orient this vertically because we feel that's the best way we're going to get a quality print out of this. And the user interface is very, very simple on GrabCAD to be able to move our parts around for a successful build. So here I'm going to take this file and I'm going to adjust it to my liking. So I'm going to move this around because I'm picky, and that's where I want it for right now. And then I'm going to adjust it vertically. Okay, so I'm going to stand it up on its edge so we can print that. And now I'm going to adjust this because this is still too wide on our axis to be able to fit it on the build platform. So I'm going to adjust this. I want to go the other way. 45 degrees, and I can automatically orient that part on here so it fits. Now the second thing I'm going to do here is, now that I've got it oriented the way I want, is I need to adjust my parameters for the build. I'm going to come over here and I'm on my trace settings. Is right now our Fortus 450 is in ABS M30, and what we're going to do is we're going to change that to ASA. Now we're going to be using ASA because it has UV resistant capabilities. This cooler cover is going to be out in the sun. It's going to get used a lot, and what we don't want is any fading that's going to go on. And ASA is a very good material to be able to use to be able to hold up to the rigors of UV light. Okay, we're also going to add in the sacrificial tower. All right, that's just good practice. Now you notice it lights up here in red because it automatically oriented it off the build platform. I can just come back here and rearrange the tray, and it's going to put it in its best place for that. Okay, next thing I'm going to do is I'm going to come down and I'm going to check my model settings, and as far as my infill styles. Now the old cooler color was hollow. There's nothing in it. So that also probably lent to why it cracked when someone sat on it. We don't think that a solid cooler cover is really necessary here. It would be very, very heavy. It would use up quite a bit of material. So we're going to go with a sparse double dense infill, which is going to create a crosshatch on the internal structure of the part, which is going to give it added rigidity to the part without using up a lot of material. All right. Then we're also going to choose our support style, and we recommend using Smart on this. It's a fairly simple build. In the system, what it'll do is it will create the sacrificial support on our build in the best way possible for strength, but also reducing as much of the material that's used that'll eventually be either broken away or taken away using a soluble support. Okay. Now, one other thing that we have going on here is this is a fairly tall build. So we want to add in a stabilizer to ensure that the part doesn't slide back and forth during the process. So down here in the selection menu, we're going to go to our stabilizers. It's going to create a preview of this stabilizer based on the default settings, but we're going to make some adjustments to those default settings. Okay, from here it's going to show us a preview on how high this particular stabilized wall is going to build, and we have the ability to adjust that up and down. So I'd like it around 9 inches, so I'm going to go ahead and adjust that setting to 9 inches. And then you can also adjust how many points of contact you want this to make. And it's a fairly simple item, so we're just going to have 2 points of contact. Okay, I'm going to click right there. And what it's going to do, this is going to generate a preview as to where the stabilized wall is going to go, and these green arrows indicate where exactly on the part this stabilized wall is going to be built. Now right now we have a contact point here on the back side and a contact point here on the front side, and that's a little bit of overkill. I don't think we're going to need all that, so I'm going to take that stabilized wall and I'm going to wrap that all the way around, and I'm going to bring it over here to the back side, and that way we have a much smaller stabilized wall on the back side of the part. And again, it's going to regenerate a preview for us. Okay, so here we are. We're seeing our stabilized wall. It's going to be on the back side of the part, and we chose to put it on the back side of the part because this would be the part that primarily you don't see, because it's going to be inside the cooler, leaving the overall front where it is. Now, in noticing some of this, I think I'd like our depth of this stabilized wall just to be a little bit different. So I'm going to change the depth of this stabilized wall to 3 inches. And it's going to give me a new estimation once I do that. Okay, now we've got a new 3-inch stabilized wall here, and it looks very good. I'm very, very happy with this. We're going to have a successful build here. Okay, so last thing I'm going to do is I'm going to come down. I'm going to make sure that my arrangement is good, which it is. And now what I can do is I can come over here and I can do an estimation. And what the estimation is going to do is it's going to go through and it's going to calculate how long our build is, how much model material is going to be used, and how much support material is going to be used. We now have our estimations here, and our cooler lid is going to take a day and almost 10 hours to print, and it's going to use up 77.92 inches of model and just over 10 inches of support material. And it's certainly great to know what your estimations are, especially when you're going through and printing your parts, to be able to go through and ensure that you're printing them and you can reorient them however you want to either reduce how much model or support you're using, whether you want to increase your layer heights to reduce time. GrabCAD has all those options. So if you're interested in GrabCAD print, again, you can go to grabcad.com, and don't worry, we're going to put it right down there at the bottom in the description for you to be able to find. So from here, what we're going to do is we're just going to come down here and hit print, and we're going to send this right to our Fortus 450, and we're going to print this cooler lid out. Alright, well, thanks for joining us, everybody, and watching our project recreating this 1970s cooler cover. It was 50 years in the making, but it was a lot of fun doing.
And anytime you need the real world in the computer, in CAD, with 3D scanning, you can do it.
Well, guys, I think there's only one thing left to do here. Pop off the top and enjoy some beers.
Woohoo!
Thanks, everybody.